Hello friends, welcome back to this video on analog communication. In this video, we are going to discuss the balanced lobe detector. So in my previous videos, I have already discussed the demodulation of FM signal, its limitation and the simple slope detector. I hope you all have seen those videos. If not, I recommend you to watch those first. So I was talking about the frequency discrimination method, and in that I told you we have two methods in the frequency discrimination method. First is simple slope detector and second is balanced slope detector. So I have already discussed the simple slope detector and I have told you that how we can convert the FM signal into AM signal and how after that we can detect the message signal with the help of envelope detector. So here also we are using the simple slope detector, but we are modifying it. So there were some drawbacks in the simple slope detector which are overcome by the balanced slope detector. The main drawback was the linearity problem, which I discussed with the help of waveforms as well. So the linearity problem can be partially overcome with the help of balanced slope detector. So I can say balanced slope detector is better than the simple slope detector. So I hope now you understood why balanced slope detector was discovered. So now here we will see first the circuit of the balanced slope detector. So the circuit is quite similar to the simple slope detector. So here we have input signal. So input signal is the modulated FM signal. So now in the balanced slope detector, again it is connected to a capacitor like the simple slope detector, which is connected to a inductor. So it's a tuned circuit now. So this is CP, this is LP, and this is tuned circuit. I am calling it tuned primary because here I am using it as a transformer, and now I'll be connecting it to the secondary inductor. So this is LS. So now here I am tapping the secondary inductor. So this is center tapped secondary. So here it is L2, here it is L1. So now here I am connecting it to two capacitors. So this is C1, this is C2. So now the only difference between the simple slope detector and the balanced slope detector, that here I have center tapped the secondary inductor and here I have used two capacitors. So here we'll be having two tank circuits. This is my first tank circuit, the upper tank circuit, and this is my lower tank circuit. I hope now you understood how I have three tank circuits. So I'll be tuning it to three different frequencies. So now after that, it is connected to the diode 1. So this is diode 1. It is also connected to a diode which is diode 2. So now after that, it is connected to a capacitor. So now what I did, I just connected the upper circuit to first diode. The diode D1 is an ideal diode. I connected the lower circuit to a diode D2, which is also an ideal diode. So here we have the capacitor C1, the capacitor C2, which is connected to resistor R1 and resistor R2. So from here you can see clearly that this circuit is an envelope detector, and this circuit is also an envelope detector. So we have two envelope detector, and if I see this circuit, so here I can see that this upper part is a simple slope detector and the lower part is also a simple slope detector. So here I can say the balanced slope detector is a combination of two simple slope detector. So now I hope you are aware about the simple slope detector. If not, I recommend you again to watch my previous video. So here this is first simple slope detector, this is second simple slope detector. In the simple slope detector I had envelope detector, so it is the first envelope detector of the first simple slope detector, and this is the second envelope detector of the second simple slope detector. So when these are combined, it is forming a balanced slope detector. So here we have three tank circuit. So the primary tank circuit is tuned at frequency Fc. This tank circuit T1 is tuned at frequency Fc plus del F. Del F is the frequency deviation, and the tuned circuit 2 is tuned to the frequency Fc minus del F. So now here I can write primary tank circuit, or TP is tuned at frequency Fc. Now in secondary we have two parts, the upper part and the lower part. So T1 tank circuit is tuned at Fc plus del F, where del F is the frequency deviation, and T2 tank circuit is tuned at Fc minus del F, where del F is again frequency deviation. So now here we will see how these are making a more linear gain than the simple slope detector. So I already told you the ideal characteristics. So the ideal characteristics of the frequency discriminator is like this. So here we have Fc, and on the y-axis we have voltage. So the voltage is varying linearly with the change of the frequency. So here we have Fc minus del F, and here we have Fc plus del F. So this is the ideal characteristics of the frequency discrimination method. So according to this characteristics, I'll generate an ideal AM wave. The ideal AM wave is detected by this envelope detector. So I hope you remember this. I discussed about this in my previous video as well. So now let's see the working. So in the working, so this is my first tank circuit and this is my second tank circuit. So the first tank circuit is tuned at the frequency. So this is the first tank circuit. It is tuned to the frequency Fc plus del F, and this is my second tank circuit. It is tuned to the frequency Fc minus del F, and Fc is at exactly in between these two circuits because del F is same. So now Fc is at the center point. So this is the frequency axis, and this here on the y-axis. So here I'll be making the y-axis. Y-axis we have gain. So this graph shows me the frequency versus gain characteristics for these two tank circuits. So now let's assume we have a modulated circuit, modulated input here. So the modulated input is tuned to this primary. With the help of primary, it is tuned to the secondary circuit. So in the secondary, if the modulated input is having the same frequency as the carrier. So let's suppose first I am finding out the carrier frequency is equal to the modulated frequency. So F is equal to Fc. In the first case, I am saying that the frequency which is coming from the modulated signal is equal to the carrier frequency. So that time let's see what will happen in this circuit. So if I see this circuit, the carrier frequency will be coming here, so it gets coupled here. So here will be having the carrier frequency. So the carrier frequency is going to the upper half and the lower half. So now the upper half will be having this characteristic. So the upper half has this frequency versus gain characteristics. So according to the upper half will be having this gain at Fc. So the gain at Fc is this, which is represented here. So now if I come to the lower half, at the lower half also I'll be having this gain. So the gain is same for upper half as well as lower half. So now if I talk about induced voltage at T1 is equal to induced voltage at T2, because the gain is same for both of the tank circuit. For Fc plus del F it is this gain, and Fc minus del F the gain is same. So the induced voltage will be same. So if I talk about the voltage at diode D1, so I can say voltage at diode D1 is equal to voltage at diode D2. So now from here I can see the lower circuit is positive for my negative voltage. So lower circuit will give me the negative output and the upper circuit is giving me the positive output. So now when VD1 is equal to VD2, so here we have induced some voltage at R1, the envelope detector will detect it, and at the R1 will detect some induced voltage. So V at R1 would be equal to V at R2. So from here also some voltage is coming. So now V of R1, if I talk about the amplitude only, so here amplitude of the voltage at R1 is equal to amplitude of the voltage at R2, and the output voltage V output T is given by amplitude of the voltage at R1 minus amplitude of the voltage at R2. So now if both are same, the final voltage V output T is equal to 0. So I can say when my message signal or the modulated signal is having the frequency which is equal to the carrier frequency, so that time the output voltage will be 0. So from here we deduced it. So now let's analyze the circuit for the frequency which is in between Fc and Fc plus del F. So now here we will see what will happen if the frequency of the modulated signal is in between Fc and Fc plus del F. So now let's see this circuit. So let's suppose an in between frequency is coming which is greater than Fc and lesser than Fc plus del F. So now it is more close to this circuit. So here I'll be having, so this is the gain of the lower circuit. So now let's suppose I am having this frequency. So if I talk about the tuned circuit one, so if I talk about this tank circuit one, the gain of the T1 is given by this gain and the gain of T2 is given by this gain. So the output voltage would be the voltage induced at D1 minus D2. So now when the gain of first tank circuit is more, here the voltage induced would be more and here the gain is less. So you can see the gain by tank circuit T2 is less, and from here we can see the induced voltage would be less. So D2 would be less, D1 would be high, V output would be VR1 minus VR2. When D1 is high, induced voltage at R1 would be high and R2 would be less. So VR1 minus VR2 would be greater than 0. So now I can say induced voltage at R1 is greater than induced voltage at R2. So now I can say voltage at D1 is greater than voltage at D2, or V output is equal to VR1 minus VR2, which is greater than 0. So it is positive whenever we have the frequency in between Fc and Fc plus del F. So whenever we have frequency Fc plus del F, we will be having maximum gain here and the minimum gain here. So the difference would be maximum. So at Fc plus del F, we will be having V max. So now V output T is equal to maximum voltage. Now if somehow I'll be having frequency more than Fc plus del F, so here I can see the gain will decrease and here also it will decrease, and the difference would be now lesser than V max because the gain here would have decreased. Can it happen? Fc plus del F is the highest frequency. My modulated signal will never have frequency greater than Fc plus del F. So we have to restrict up to here only. So now at Fc my voltage was 0 and after that it has increased. So it has increased up to Fc plus del F. So now this characteristic is followed. So now here let's see what will happen if my frequency is in between Fc minus del F and Fc. So now if I am supplying a frequency which is lesser than Fc, so here the frequency here would be Fc minus del F and Fc, in between Fc minus del F and Fc. So whenever the frequency is lesser than Fc, the T2 circuit will be providing more gain. So you can see from here, if I am finding out this frequency, so here the gain provided by T2 is more, the gain provided by T1 is less. So now from here I can say the voltage induced at diode D1 would be less, the voltage induced at the diode D2 would be high. So now VR1 would be less, VR2 would be high, and V output was VR1 minus VR2, which would be negative. So I can say induced voltage at R1 is less than induced voltage at R2, or I can say VD1 is less than VD2. Now V output T is equal to VR1 minus VR2, which is negative. So it is less than 0. So now if I talk about Fc minus del F, so let's see what will happen at Fc minus del F. This circuit will be having maximum gain and this will be having minimum gain. So here we are providing maximum gain and here we are providing minimum gain. So here the difference would be most negative. So here I will be having V minimum is equal to V output T. So now I hope you understood how I can analyze the working of the balanced lobe detector for different frequencies. So here if I am decreasing frequency below Fc, my voltage is going below 0. So at Fc the output voltage was 0. If I go above, the output voltage becomes greater than 0 and it reaches up to V max, and when I go down it reaches up to V minimum. So if I talk about the characteristics, so the characteristics are like this. It is frequency, it is gain. So the characteristics are, this is characteristics of balanced slope detector. So I can say it is following S type characteristics. I hope you are agreeing with me because it is not perfectly linear. The characteristics can be found out using combining the upper gain and the lower gain. When these two are combined, I am getting approximately S kind of characteristics. So now we'll be talking about the drawbacks. So the first drawback is that it is not perfectly linear. So not perfectly linear characteristics. So now if I talk about the second drawback is the limiter circuit. We cannot use the frequency limiter circuit. Frequency limiter circuit, I hope you remember, it was used to make the amplitude of the modulated signal constant, but we cannot use here. So limiter circuit can't be used here. So which makes the amplitude of the modulated signal change with respect to noise, and which will cause error in the system. So now the third drawback is we have 3 tank circuit, and 3 tank circuits are tuned at different frequencies and which are connected to a transformer. So having a transformer which is connected to 3 different frequencies, designing it would be a very difficult task. So 3 tank circuit at different frequencies, FC, FC plus del F and FC minus del F, is difficult to tune. So now I hope you understood the drawbacks, but the only advantage is that it is more linear than simple slope detector. So here I'll be concluding my session. I hope you understood each and everything which I discussed here. If you still have any doubt, you can connect to me with the help of my mail ID, or you can write your comment in the description box below. If you like it, share it with your friends, subscribe the channel and push the like button. Thank you.